figure out in such a way that all the t's are on one side, all the p's are on the other. In general, I know if a differential equation is separable if it can be expressed as some function f evaluated at one variable times some other function g evaluated at the other variable. And so in a dE where dy dx is isolated, or in this case dp dt, if I can interpret the right-hand side as a product of two functions in those two variables, it is separable. Well, certainly I can say that in this case because I see no t's. And in separating variables, I think I now can claim that 1 over p times L minus p with respect to p is going to be the first differential. I think the second one is merely that constant k of the integral times 1 with respect to t. Now I think on the left-hand side, p is a k to anti-differentiate. I think I'm simply left with a kt plus c. On the left-hand side, the integrate, I'll have to you guys, how do you integrate the left-hand side? Partial fraction decomposition. And with partial fraction decomposition, we get the integral of something over p plus something over L minus p with respect to p. Well, you guys can do this on our heads. Like I said, I'm just not feeling well. You guys, as usual, aren't going to help me. I'll write it so you can read it. Sorry. Yeah, I just checked it. It works.
1 over L?
1 over L.
Okay. Oh, L is a constant?
Yeah, L and K are just constants, but L specifically is a carrying capacity for whatever this population is modeling. And I maintain that makes my life so easy, because now on the left-hand side, I've got 1 over L times a natural log of the absolute value of p over L minus p, being equal to stuff. You remember what your job is. It's to shake me up.
L is the carrying capacity.
Yeah.
What's the other constant?
The constant k actually depends on what the population is. It's a constant that I do not have yet, but just treat it as a constant through the anti-differentiation process.
There's not a single number in there. Well,
Ooh,
1.
We wouldn't know what numbers would we?
1.
We wouldn't be abstract.
Abstract is confusing.
Oh, but wait a minute. This is a differential equation we're trying to solve for.
dp dt? Or something?
I'm trying to solve for p as a function of time. So let me isolate p. To isolate p, I'll clear fractions. I'll get rid of the 1 over L. I'll exponentiate both sides. And in exponentiating both sides, I see the absolute value of this ratio. I can't write it all today. I said the absolute value of this ratio is equal to my, I don't know, is it just simply this? Oh, did I forget my absolute values? Or shall I say, p over L minus p is equal to b times e to the KLP pound. You guys, so far so good?
Why switch from... Oh, never mind.
You guys, can I just take another break? I don't like all these letters, and I don't see anything related to p sub naught, so let's take a break and use the information given, namely that p evaluated at 0 is equal to this constant p sub naught. I think when I plug p sub naught in for p and 0 in for t, I think it generates this number. I see p sub naught over L minus p sub naught is equal to my constant b times e to the 0 power, but that's just 1. In other words, I just came up with a value for b written in terms of those constants p sub naught and L, which is nice, because L is a known value by carrying capacity, and p sub naught is a known value of the initial population. So if you guys don't mind me back substituting. Does that tell me over here that P over L minus P is equal to P sub naught over L minus P sub naught times e to the KLT power? Shoot, you guys just lost track again. What I'm trying to solve for? What am I trying to isolate? P. Treat everything else for a moment as a constant, since I'm trying to use my math B skills to isolate P in this equation. I really want to solve this differential equation. So keeping in mind that P is the only variable we're looking at in this equation, don't take that the wrong way. I know T is a variable. I just mean in terms of using my math B skills to isolate P, I'll treat it as a one variable. I'll get rid of fractions. Well, I'll get rid of fractions, then of all P. And I think that tells you that P is equal to my P sub naught over L minus P sub naught e to the KLT power times my L minus B. I'll get rid of parentheses. I'll bring all the terms involving P to one side. I'll factor out a P and divide both sides by what's being multiplied to it. Well, that means I'm dividing both sides by 1 plus all this. But that's going to give me my LP naught over L minus P sub naught times e to stuff. All over. My 1 plus my P sub naught over my L minus P naught times e to that power.
Is this some sort of proof or an actual problem?
Both, in a sense. I was a problem or an exercise of solving this differential equation using my separation of variables technique, but also I'm also deriving out of thin air what the population model must look like if the logistics DE really is an accurate assessment of what's going on with this particular populations.
So what does P sub naught really represent?
P sub naught merely represents the initial population. It's the P value when T is equal to 0.
Okay.
Oh, you guys, I don't like it. It's a mess, isn't it? Can I get rid of the smaller fractions better than the big ones? I'll multiply top by L minus P naught. And that tells you that population can be expressed this way. You know what? I still think I'm unhappy. I see e's all over the place. I think you and I can algebraically massage the right-hand side so much more nicely if we merely multiply top and bottom by e to the negative KLT power. And if I multiply top and bottom by e to the negative KLT power, I think my population over time can more aesthetically pleasingly be represented in the following fashion. Carrying capacity times initial population over initial population plus their difference times e to the negative KLT power. Now, I'm of course assuming L is a positive constant, but let's assume K is a positive constant as well. Let's see if I really blew it. T is equal to 0. What should P be? What should it be?
Should what be?
What should P be if T is equal to 0? P sub naught. Let's see if it is. I plug 0 in for T. E to 0 power is just 1. Parentheses are now superfluous. P naughts cancel. I only have an L downstairs. Cancel the L upstairs, and look at that. What's left over is a piece of naught. Now, if I'm accurate with the graph, remember how I said over time, here's what this kind of population model should do, like that. As T increases that bound, what should the population be? It should be L. Let's see if it is. If K and L are indeed positive constants, as T increases that bound, I think this exponent decreases with that bound, but e to some power that decreases that bound goes to 0. I'm just left with that fraction. But now the P sub naughts cancel, I'm just simply left with L. I still could have made some mistakes. I'm just saying, certainly got that right. And so from now on, I do have a mathematical model describing populations that behave in this fashion. But like I said in class, it's the same thing holds true when it comes to, I don't know, I'm just still too tired, you guys, I'm sorry. Epidemics. If I started spreading a rumor in this class, rumors behave exactly the same
On
fashion.
the, you let t equal 0, and then the second time around, what did you let t equal?
I allowed t to increase without bound,
Oh.
to see if my curve really does level out with my L, like I suggested. You might not have that in here, I thought you gave us examples. That's okay. Yes, Tyler?
On this last equation for P of t, the P in the denominator, is that supposed to be P naught or just P? Or does it matter?
Sir, I am so very sorry. It's that piece of knowledge. Now I got it. I apologize. I've never derived the solution to that very special differential equation without somebody giving me a hard time. You guys are stories. Oh, you guys, can I cheat? Does anybody know if I can cheat? Did I put anything online or not? Oh, I did. Okay, I didn't realize it. So you guys, so I could just get away with cheating in class today, speed up a little bit, not write everything down. So, you and I just derived the solution to the logistics difference equation. And suppose I do have a population of 2 beavers known to have a carrying capacity of 10, where the constant k is equal to 1. Are you able to answer the question, when will this population reach 4? And we don't have to answer the question if you guys think this is too basic. It's entirely up to you.
No, let's answer it.
Let's
For
answer it.
laughs and giggles.
Good, good. I can't, where are my erasers? Ah. So the carrying capacity is known to be 10, the initial population is known to be 2. Let me rewrite my function. I think this output, as an expression, t is nothing more than, you guys, so 10 times 4 is that. All of my initial population. I think I made a mistake, didn't I?
Your piece of t is 4, is equal to 10 times 2.
Thank you. So I wrote in my 4 times the initial population. It's just 2, isn't it? All of my initial population, plus the difference between my carrying capacity and initial population. And I'm raising e to the negative 10t power. You guys just make sure I put in the right numbers. Or how about saying this to be lazy? I can reduce. And if that's my mathematical model, then how do I actually answer my question? So plug 4 for p of t, solve for t, piece of k, isn't it? Sorry. Now I want to solve for t, I should say. Multiply. Get rid of fractions. It's certainly a math equation, isn't it?
Where did the y come from?
Where did the y?
That's a 4.
Oh, that's a 4?
So getting rid of fractions. Isolating e to the negative 10t power. Take the log of both sides and divide both sides by negative 10. Oh, shoot. You guys, did I make a mistake? This is supposed to be how long it takes for the population to grow to 4, and I got a negative time value? I got a...
It's because the derivative is negative.
Ah, good. There is no mistake here. The natural log of any number between 0 and 1 is going to be negative, and negative times negative is positive. Thank goodness my world makes sense. and it's measured in years. Are you there? You guys look so excited. If you are there, let's go to my next question. I've got a pond whose volume is fixed at 200,000 liters. Hold it, I can draw that. There's a pond. Here's how much fluid's in it.
Quick question before
Yes.
you go to the next one. So if we, for this one, why is the carrying capacity necessary for these type of problems? What if we wanted to know, I
Oh.
guess, for example,
You want to know what?
like, for example, we wanted to know how long it would take to get to 11 beavers. What would happen?
I see your point. You know what? If I did have this function and I played the lemon for t, I can take a look at this and I can see clearly that I won't get any solutions. When you end up solving for t, you end up taking log of the negative quantity. And that kind of indicates that if this mathematical model is accurate, then my population will never become positive. And take this with a grain of salt. Or maybe I'm just talking too fast, you guys. I'm not trying to suggest that all populations, excuse me, grow in this manner. I'm just saying if I do have a population whose rate of change is, oh, there's an equal sign missing in here, is proportional jointly to the population and the difference between the population and carrying capacity, then I can solve a DE, and there's my mathematical model giving me the population after t years. But that's a huge assumption, that all populations behave like this, graphically speaking. I know I've mentioned, didn't I? Predator-prey models, where one population is chasing the other in a very sinusoidal fashion. Have I mentioned that? Really? Do this. Stick a population of rabbits in the Bitterroot Valley, Montana. Is it not true the population is going to grow exponentially, assuming there's no predators around? At least initially. I know somewhere along the way it's going to have to start leveling off or something like that, but for the meanwhile, just for the short run, I think my population is going to grow exponentially. They're rabbits. However, if I, as a federal government, introduce wolves into the Bitterroot Valley, that population of wolves sees all the rabbits, the population of wolves is very happy. It's going to start growing. In fact, it's going to grow so much that maybe it's going to decimate the population of rabbits. So rabbits don't level off, they die out. Well, maybe not completely, but they decrease in their population significantly. And there's so few rabbits now that the wolves are hurting real bad, and they start declining their population. Until there's so few of the wolves, the population of rabbits increases again. And we just cycle back and forth. Not all population models behave like this. I'm just saying it's a better model than what I had before, where y was equal to p sub naught times e to the kt power. That's all I'm suggesting. Give me another population. What's one of the most famous mathematical models for populations that you're aware of? Math D.
That we've studied.
Yeah, it's like you studied back in Math D. What's that?
The growth and decay,
Yeah, the E stuff that we had last time. That's
I
true.
forget.
Mosquitoes?
What was that?
Mosquitoes?
But a population model, mathematical model, Fibonacci sequence. Actually, Fibonacci came with a sequence by looking at the population of rabbits, to be honest. You know the Fibonacci sequence, right?
Do you want to show us really fast?
2, 3. Do you guys see what I'm doing? Every single entry I have in a sequence is the sum of those two predecessors. Yes, sir.
Isn't the ratio between them the golden ratio?
And I can prove that too, yeah. I have my math D students derive it. Yeah, I have my math D students derive it, that when you take a look at the ratio of any Fibonacci number to its predecessor, the further you go out, you're just going to get the golden ratio. Yeah, I agree. Can I bore you with a personal story?
Yes.
My first wife is mathematically illiterate. Didn't understand math, I didn't like it. I was a full professor at the University of Montana, and she wouldn't let me bring books home. She couldn't stand math. She insisted there's no applications for it anyways. One day I moved. Is there anybody here from Connecticut? Okay, I can tell the story. One day I moved across country with kids, and and got to Connecticut, because I got a job there as a faculty member. And when I got there, I didn't do my homework. I never found a place to live. So we're all just in this motel room. I'm making phone calls all day long and trying to get some place to move into. I never was an apartment, a house made no difference to me. And after like 4 days, no one called me back. And I finally got this guy on the phone. I said, what is going on in Connecticut? Nobody's calling me back on these, I'm just trying to rent a place. And he said, we have so many people want to rent. We get so many applications. We don't go through them all. We just take the cream of the crop and we call that one person and say the place is yours. And so I was kind of getting annoyed, and I could tell he was getting annoyed with me. He said, look, I'm sorry. I know you're in a bind, but I just can't help. I'll tell you what, I'll give you a break. If you, right here on the phone, right now, can rattle off the Fibonacci sequence, the place is yours. So she finally had to admit there were some applications to man. So you guys, can I come back now to the second example? So a pond whose volume is fixed at that has 2 feeding sources, 1 stream, supplying the pond with 20 liters per minute. And the other is supplying with 30 liters per minute. The first is runoff by nearby mountains and is clean. The second is runoff from nearby irrigation practices and contains 20 grams of salt per liter. So 20 grams per, what did I say? A liter? Another stream drains the pond at a rate of 50 liters per minute. So I'm leaving at a rate of 50 liters per minute. Over time, what's going to happen with the level of water in the pond? I think it's going to stay the same. I agree with you. Because of some of these 2 flows of fluid coming in, it's the same as the rate of going out. Now,
Well, what does the salt have to do with anything?
a lot. Because I think over time, watch this, just maybe clean water,
Uh-huh.
but I think there's a concentration of salt being built up in the pond.
I see.
As a matter of fact, that's actually the question.
Oh.
Find a function that expresses the amount of salt S in the pond at time t. And find a function C that expresses the concentration of the salt in the pond at time t. We've got 2 questions in there. Can we forget about the second one? Let's just concentrate on the first. And I think to answer the first question, there's enough information that will allow me to literally create out of thin air a differential equation. And if I can solve the differential equation, that is to say, if it's separable, I'll be able to find a function. Let's give it a shot. So let's build a function for S by first writing a differential equation. That tells me that the rate at which S is changing in the pond itself could be interpreted as a difference between the rate at which is changing of the fluid coming in minus the rate flowing out. And I think when it comes to the rate at which the amount of salt is coming into the pond is changing as following. Oh, you guys, staring us at the board. Here's the rate of fluid coming in. Here's the concentration of salt in that fluid coming in at this rate. And so I think the rate at which the salt is coming into the pond is going to be nothing more than the product of the rate of fluid with the concentration of salt in that fluid. I might make some silly mistakes. Can I go by unison for a minute? Minus the concentration of salt in the pond times the rate at which the fluid is flowing out, but the rate at which the fluid is flowing out is going to be 50 liters per minute. I just need to multiply this by the concentration of salt in this particular pond. Oh shoot, you guys, it wasn't given. Why not? Because, yeah, I have to find it. It's not a constant. As a matter of fact, if my pond's initially clean, don't you guys think the concentration or the amount of salt, both, are going to increase as far as the fluid is concerned in the pond? Can I make an assumption here? Can I say that there's some great mathematical god with a big spoon always stirring the pond? So the concentration at any position in the pond is going to be the same. And that being the case, I think, therefore, the concentration of salt in the outflow is going to be the same as the concentration of salt inside. And I think the concentration of salt inside the pond could be interpreted as a ratio of the amount of salt measured in grams to the amount of fluid, which is nothing more than 200,000 liters. So I'll multiply the rate at which fluid is flowing out by the concentration of salt in that body of water going out, which is this many grams per, I've lost it, is it 200,000 liters? Is that
Mhm.
right? Oh, can I just check my units, you guys, in case I made a mistake? The L's cancel. The first term's measured in grams per minute. That would be the rate at which the salt's coming in. My second term has more cancellation with L's. Oh, thank goodness. It's a quantity measured in grams per minute again. Seems like I have made mistakes. Having said that, let me now suppress my units. I see the rate at which S is changing with respect to time is nothing more than 600 minus, is that a 50 over 200,000 times S? Can I clean that up a little bit? Does that mean ds dt is equal to 600 minus, I don't know, you guys help me with this, 1 over 4,000, I think? You just double check my record. Yes or no? Is that separable? I asked. Yes or no? Is that separable?
Yes.
Oh, definitely separable, isn't it?
Are
Yes.
we factoring in the clean water coming in or not?
What a good question. You're right. I didn't factor it in. So you guys, let me put it in. As far as an extra term is concerned, dealing with the amount of salt coming in from the second flow, which I did not consider, is coming in at a rate of 20 liters per minute. But what's the concentration of salt?
0.
So I didn't include it. It just drops out. But at least it justifies it drops out. And to solve this DE, let's give it a shot. Okay, you guys, I insist I don't want to read that far. If we were to separate variables, wouldn't we get this? The integral of 1 over something ds being equal to the integral involving 1 with respect to t. Help me with this, what's downstairs. Is it 6,000? 600 minus,
1 over 4,000.
got it, times s. And so if I were to integrate on the left-hand side, what do I get? You guys.
1 over 6, or it's 7.
How?
4,000
Negative
or
4,000.
negative 4,000 S, or natural log of S.
Yeah.
600.
Oh,
Minus S.
Minus 1 over 4,000 s.
I don't know what's going on.
This is just
Plus
the easy
C.
part, right?
Plus C.
I can hear you.
Plus
Equals.
equals T plus C.
Thank you. Pretty there. If you are, let's try to isolate the s to come up with our function. I will divide both sides by negative 4,000, exponentiate both sides. I think I come up with this. Would that be e? It's a negative 1 over 4,000 times e. Times e to the negative 4,000 c. And I got plus or minus. So help me with this. Yes or no? Look above my fingertips. Yes or no? Is that a constant?
Mm-hmm.
Yeah, it is. I just call it what it is. Namely constant. I got 600 minuses being equal to some constant a times e to that power. Yes?
For the plus or minus E, would it be C over negative 4,000? Because you're dividing by
No,
negative
sir,
4,000.
you are right. I'm so sorry again, you guys. I'm just full of it today, aren't I? Isn't this supposed to be c over 4,000? Negative? I guess I did perform too many math steps at once. Regardless of my mistake, it got absorbed. I'll just call it constant A. And if I were to isolate s in my equation, I can't. You guys, I ran out of room. All right. To solve for S, let's first subtract 6,000. Now I'm gun shy. I'll make sure I show my steps. I'll multiply both sides by negative 4,000. Okay, you guys, it's time for me to slow down again. I think I'm missing a 0. Yeah, that's better. Is that minus A or plus B times e to the power? Oh, you know what? There's a constant B in here. I can figure that one out because I guess I got some initial value conditions. I turned the computer on. Does anyone remember what the initial population was? Did I say?
No.
Isn't it 0?
Yeah, can we just assume it is? I'll put that in words. Let's assume the pond originally is clean. Let's assume there's no salt in the pond initially. That being the case, I do know that S evaluated 0 is equal to 0, but that necessarily implies from this equation right here. That necessarily implies that 0 is equal to 2,400,000 plus B times B times 1. It just means B is negative 2,400,000. Let me rewrite. In rewriting, I see that S as a function in T is specifically 2,400,000 times 1 minus e to the power. I have just built my function, given the amount of salt at time t. And I was just simply solving everybody. It's equal to e, nothing more.
Do we have to change our constants every time, or can we just keep them?
You know what? That's a really good point. Check that where I substitute 0 for T and 0 for S. I went here. I could just as easily gone back up here. It just means the value of that constant C will be found. Now I got to go through all this again. That's why I'm being very careful in labeling how I've changed my constants. You can go back to any stage you normally please.
So S of 0 equals 0, that was actually stated in the
Well,
problem.
I'm going to turn it on again in a moment. I certainly hope it said that. If it didn't, I really meant to say the pond's initially clean. There's no salt. You guys, help me again or shake me up. Any questions? That wasn't that bad, was it? Maybe a little bit of thinking, just a little bit of thinking in terms of setting up the differential equation. Okay.
So, would this be an ideal test question?
Oh, I love these questions, yeah. A lot of fun. If you don't have any questions, can I get rid of them?
Before you do,
Yes.
the integral that you built on in the very top of that board, that came from.
This came from over here, I separated variables. So what I really did, David, is I divided both sides of the entire quantity. It came downstairs on the left-hand side.
Okay.
And then I brought the TT over here.
Oh, I see.
Now you guys don't say things this way. Don't say, oh, he multiplied both sides by dt. I did not. There's no such thing as multiplying both sides by dt because dt by itself is not a quantity. That's not a differential. I'm talking about the process of differentiating s with respect to time t. Now, if you think it's kind of hokey the way I'm using my hands and separating out variables, let me justify it with my purple pen. You know, at this stage of the game, if I differentiate respect to t on the left-hand side and differentiate respect to t on the right-hand side, I think what I end up getting is nothing more than this. So it's really just a reverse process of differentiating implicitly with respect to time t.
Okay.
It's really a chain rule being applied.
What would you call that with words? Like, what would you call what you did there?
Yeah, in English, I'll say the following. To go from here to over there, I separated variables. Nothing more. So, you guys, let's get back up. Oh, we can't. Shoot, I forgot. There's another question. The first question was, can we find a function for the amount of salt in my tank at time t? I did. Now you can plug in whatever t value you want, you get the corresponding amount of salt. But I also asked the question, can we build a function for the concentration of salt? No, just write the answer.
Just that over the
It's just the amount over,
the liters.
over the number of liters of fluid I had in the pond. I think the concentration function is exactly what you see on the board divided by, thank you, 200,000. That would be my concentration.
The whole E included in everything?
Yeah, the whole thing divided by that constant, or just how I just absorb it with this constant.
Oh, okay.
Yes.
On this side, can you point out the carrying capacity, or is this a different type of problem?
Whoa.
Like, can the
You know what?
pond be
This
all
is
salt?
actually related to what I was talking about with carrying capacity in the sense that I do think with the amount of salt in this tank at time t levels off. Think about it.
As T goes to infinity, it can't ever fill all the way full. Or it'll be all the way saturated, so.
I like it. Or how about saying this? As time goes by, I will my limit of the amount of salt in my tank is going to be limited to 2,400,000 grams. Are they measuring grams?
Mhm.
I think so. So there really is a leveling off process. It's just unlike the logistics DE, I'm not really saying the rate of change is jointly proportional to two quantities. I set my D up differently.
Oh, so this isn't logistics?
This is not an example of logistics model because I don't have those two factors in the original DE.
Okay, what type of problem is this?
Oh, this is just a standard trying to create a differential equation, mathematically modeling the situation. I feel so awkward today because I like to spend a lot of time discussing differential equations. And when you guys leave this semester, it's not the case, it's really that we've lied to you. It's not generally the case that someone's just going to throw an integral at you in applied mathematics or applied sciences and say solve the integral. What often we do is we stick our heads out the room and we look at nature and observe some quality nature has, like for example, that some populations seem to increase in such a way that they increase jointly proportional, or at least the rate of change is jointly proportional to your population and the carrying capacity minus your population. And then we solve the DE. And notice in solving DEs, I got to integrate all over the place. And so I think the greatest application to integrals is solving DEs after you stick your head out the math class door, make some observations or make some assumptions that are mathematically sound, and then solve the corresponding differential equation. Yes.
So, just kind of a little bit off topic, but if this is diff equations here, how does that really relate to linear algebra, and what exactly is linear algebra?
Are you guys aware, have I talked about Math 33 at Sierra, how we teach it? Because it's very different from what you experienced in the past. Typically when students anywhere across the country finish studying calculus, there are two immediate courses you can take after the calculus sequence. One's called linear algebra, and one's called differential equations. And most universities have these as separate classes. It's just that at those universities, these generally speaking are not prerequisites for each other. They're completely independent. One's very abstract, and one's highly applied oriented. It's just at Sierra College, what we do is we combine them into a single class. And there aren't that many institutions that do this. I know UC Berkeley does. I think Chico State and Sonoma State are the only other